Welcome to a brand new unit. This unit is on functions, and lesson 42 is an introduction to functions. So here is the criteria for success. So number one, if given a set of ordered pairs, a table, or a mapping diagram, we're going to use a definition of a function to determine whether or not the relation is a function consistently and accurately. So we're going to learn about what that looks like. And if we're given a graph, we're going to use a vertical line test to determine whether or not we have a function graphed. And finally, we're going to identify if any inputs have the same value, because again, that will help us determine if a set of coordinates creates a function or not. We're going to talk about what a function is and how to determine whether or not we have a function using the output tables as well as a vertical line test. So let's start off here with some definitions, and these are also in your notes. In mathematics, a function is a rule that defines a dependent relationship. A function creates exactly one output or result for every input. So think about this like when you were younger and your teachers gave you those in and out tables where you would have a number going in and a number going out. And what this tells us is whatever number we have going in can only give us one kind of number going out. That's what it's going to tell us. So out of all the possible input values, we call all the inputs are domains. And all our outputs, in this place, we call them a range. Now, what else does this remind you of? This kind of reminds me of, well, when I think of in and out tables, I think of my coordinate pairs when I have X and Y. And I know that whatever I put in for X creates Y, it determines the Y. This again represents a type of relationship. So think about when we would have something like this, Y equals 2X plus 1. Whatever happens to X, so like if X is 3, I can use that to determine what the Y is going to be equal to. And that would be my output. So we're thinking about it very much like this. And so let's look at this example. And what I'm going to do for this is I want us to think of the domain when we have, I'm going to put domain here and range. Here's X, here's Y. Your X is your input, is your domain. And your Y is your range. So that's the first thing I want you to recognize, and we can separate them. One way we can map this out and test whether or not a relation is a function is by using input-output tables like this, where we take the domains and the range. And what you're going to look for is it possible that every single number here only connects to one number on the other side? Okay, so that's what we're looking for, that every number here, every input has exactly one output. That's what we're looking for, exactly one output. So in this example, 2 goes in, a 4 pops out. A 4 goes in, a -1 pops out. A 5 goes in, a 0 pops out. So think about these points. For I have 2, 4. I have 4, -1. And I have 5, 0. So this is a function, ladies and gentlemen, because there's one input and one output. So yes, this would work. But let's look at number 2. And here in our second example, I've mapped it out. I've given you all these coordinate pairs, so we're going to jot them down. And I have a 3, 6, 2, 1, 8, 1. I'm going to write these in order. So I have a 1, a 2. I know I have 2 1s, but I'm going to write down 1 just one time. A 1, a 2, a 3, a 6, and an 8. And so what are my outputs? Well, I know, let's see, let's actually write them all out. Again, I like to kind of write things in order. So let's see, I have -2, -3. So I'm going to start with -3, -2, 0, 1, 4, and 5. I think I have 1, 2, 3, 4, 5, 6. Yep, I have all 6 here. All right, so let's look at our outputs here and let's see if there's exactly a 1 input to 1 output. So my 3 went to a -2. That's 1. My 6 went to a -3. So far, so good. My 2 went to 1. My 1 went to 5. My 8 went to 4. And do you see the last one, Math Marvels? This one over here. So look, my 1 also went to a 0. So this, I'm going to color it so you can see the problem. My 1 went to a 0 and to a 5. So that's a problem. That would mean that this is not a function, because I can't have one number, in this case my 1, going to 2 different numbers here. And I can see it. I can see that it was happening because I have 2 different outputs. So this would not be a function. So let's look at the last one, and just by looking at it, do you have 1 input to 1 output? Just look at it for a second. What do you think? Well, you're probably recognizing no, because my 2 went to 20 and my 2 went to 40. So this is also no, not a function. So that's what we're going to look for today. This is one way you can tell whether or not you have a function. Now, could you have 2 different numbers go to a different output? Would that be possible? And the answer is yes. I could have 1, 2, 3, 4, and I can have 5 and 6. And it could be that 2 different numbers go to the same output. And that would be okay, because I still have exactly 1 output for each input. So this is the only output for 1. This is the only output for 2. This is the only output for 3. This is the only output for 4. So that would be okay. But I cannot have one of these, like I couldn't have 1 go to 5 and 6. So we're going to try this out some more, but let me hit pause for a second so you can jot this down in your notes. And let's look at one more example using vertical line test. So here's our problem for today. We're going to determine whether or not the table represents a function. We're going to graph each ordered pair, and we're going to apply the vertical line test. So that is going to be our goal. Is this a function? That's the problem. And our facts are right here in our table. And what we're going to do is we're going to plot each pair. And then we're going to use the VLT, which is the vertical line test. And what that means is I'm going to go from each point down and see, does my line, is there any way my line would go between 2 points if I were to draw any line going straight down? So let's map out these points. I'm going to use this here. Just by looking at it, do you see anything that would tell me this would not be a function? Like if this was a regular input-output table, do I have, well, I have all these here, but do you see anything or notice anything about your inputs? Do they all have exactly 1 output? Well, I'm looking right here, and I see 4 can have an output of 10 and 4 has an output of 5. So I have 2 outputs here. That is a problem. That would be like my 4 doing this. So let's look at what that looks like and why it would fail the vertical line test. So I'm going to map -5, -6. Here's my first one. 4, 10. Second, 0, -4. -2, 1. There you go. And let's do 4, 5. Okay, and so again, a vertical line test would mean if I had a straight line going straight down, I would only hit 1 point. So that's fine. That's fine. How about at -2? That's fine. But here is the problem at where x equals 4. So this is where we have, it would fail the vertical line test. So here's my vertical line test, and I'm gonna write fail at x equals 4 because it goes through 2 points. And I can see that, and I knew that was gonna happen because 4 had two outputs, 10 and 5. So this is another way that I can tell whether or not I have a function by graphing it and looking at the vertical line test. And I would write this down in my response. No, this is not a function because I have two outputs at when x equals -4. That's right. I'm going to write that full sentence. This is not a function because there are two outputs when x equals 4. And you could always just go a little bit further if you wanted to, and you could even write the 2 points. So you have at 410 and at 4.5. So there you go, Math Marbles. Hit pause so you can jot this one down into your notes, and we're gonna get tons more practice talking about functions. Let's look at one more problem together. And here's the situation. So one that we've seen many times before. It looks like the type of problems we've done many times earlier this year. Anna rents a truck for $60 per day. She also pays 75 cents for each mile driven. And she uses the equation y equals 7,500 x plus 60 to represent the situation, where x is the number of miles and y is the total cost. Determine whether the equation is a function. So what is my question? Is y equals 0.75x plus 60 a function? And what facts do we have? Well, we have the equation y equals and what else do we know? Well, I know that this so it is kind of an in and out table. I have where x equals miles, and the number of miles I drive will determine my cost. Okay, so I know that there's a fixed part of it. There's already $60, and for every mile I drive, there's an extra 75 cents. I also know this is a linear. This is going to create a linear graph, a linear model, a linear function, because the more miles I drive, the higher the cost. So I know it's going to be something like this. And I also know this is going to be constant. The 60 remains the same, but it is going to increase at the same constant rate of 75 cents per mile, so that rate will also be constant. It's going to be an increase of 0.75 cents per mile. So I have all this stuff down. So what should be my plan for this? What could be my plan is I can graph the equation. And then I can use the vertical line test to prove if it's a function. So that could be the thing I do for this one. Just take your calculator out and you can try graphing this and seeing, is it true? Is it linear? We know it will be, but we're going to use some of our facts for this. So hit pause so we can jot this down. And let's go into our plan. And I'm going to make a very general one. I'm going to use my equation y equals 0.75x plus 60. So I already know my y-intercept when x is 0. This is 60, so I know I'm starting there. And I'm making this very general. So if this is 60, here's 0. And I also know that my slope, my m, let's use proper terminology, m is equal to 3/4. So mx, I can just see it right here, 0.75. So I can just say it is same as up 3/4. And that's just telling me it's 75 cents every single mile. That's all it's telling me. So when I go 1 mile, when I go to 1, I'm just gonna move up to $60.75. So that's gonna be my next point. That's still gonna be the cost at that point. And then if I go another one, it's gonna be another 75 cents. So the cost will be $61.50. And I'm gonna add another one, and I'm gonna be at $62.25. And all it's gonna keep doing is just increasing in that manner. And this is all about cost. So just looking at it, it is going to be linear. It would pass the vertical line test because it's just a linear graph. That's what's going to happen to the points. And I just know that just because of the format of it, it's written in slope-intercept form, y equals mx plus b form. So I know that's going to be linear. Now, some of the equations we have may look like this. We might have equations that look like this. We might end up having equations that look like this. And those will not be in y equals mx plus b form. So we're gonna play with our calculators and look at the situations. And while you actually graph them, look to see if you use your vertical line test, would it pass? In this case, yes, it passes the vertical line test. Yes, this represents a function. It is written in y equals mx plus b form, and y is a function of x. It also passes the vertical line test. It passes the VLT, the vertical line test. So we're going to stop there. We talked a lot about functions today. We can see what they look like in input-output tables. We see what it can look like on a graph. And we're going to keep exploring. Remember, what you want to see is that there is exactly 1 point, 1 output. So anywhere on our graph, wherever x is, there should only be 1 point through there. Okay, Math Marbles, get some practice in. I will see you in the next lesson.